Good afternoon, YouTube. It's Greg again from GregsTutoringNYC at gmail.com. Back again to give you guys some more knowledge pertaining to the SHSAT. This time around, I'm going to kind of focus on angles. Again, in the lightning rounds, we're just going to spend 15 minutes or so, give or take 5 minutes, just covering some basic concepts to find out if you're up to par on some of the different aspects of it. One aspect of a lot of these kind of standardized tests is geometry and figuring out angles. And a lot of kids just get bent out of shape when you're trying to process a lot of these things. Please like the video. Please subscribe to my channel as I add more stuff to this. With that in mind, let me just jump into this. I'm going to go through some kind of basic stuff. I'm going to mention the names of angles. But really the important thing is the concept, especially when you have a question that's asking you to find out angle X. It doesn't really matter if it's called supplementary or exterior or acute. It just matters that you can do the addition and subtraction based on what it should be. All right? So let me just jump in with some of this. So let's just go through some basics. First of all, when you have a question on a standardized test, make sure you're familiar with the test's conformance to its directions and instructions. On some tests, all the illustrations are drawn to scale, and you had to depend on the question to say whether or not they are following that or not. In other words, the directions might say everything's to scale, and the question says it's not. Some tests flip that. For instance, in the case of the SHSAT, nothing's to scale unless it says so. So it can say so in the words. It can also say in the legend or the key of the caption of the illustration. So it doesn't have to be in the question. It could be somewhere in the illustration saying this is to scale. As you look at stuff, for instance, you'll have different codings. This says it's an angle. We have this little square thing. That means it's 90 degrees. So sometimes you may have a figure drawn, and if it's just like this, you know this is going to be either a rectangle or a square. We don't know anything about the sides, but by virtue of them all being 90, by this little square notation, there's various notations that you need to be familiar with. This is definitely one of them. So sometimes the problem might say it has a right triangle. And sometimes it might just show this without saying that. So you just have to know that means that's 90 degrees, right? That's a right triangle. All right? So let me run through some stuff real quick, and then we'll start getting into deeper stuff. So first of all, there is a right angle. There's also acute. Acute means less than 90. Obtuse means greater than 90. And often there's a little kind of curve added in your angle. So that's acute, and that's obtuse. Okay. There's also interior and exterior angles. For instance, this is an interior angle here. This outside of here is an exterior angle. All right? So I have a kind of a tricky question. Can an angle be interior and exterior at the same time, or exterior and interior at the same time? So it's a way to think about stuff like this. Well, if we had something like a triangle with, say, a square on it, or some other shape that's kind of attached to it. This angle here is an exterior angle to the triangle, but it's inside this other shape, so it's interior to that. All right? Another question that comes up, especially when I'm tutoring kids, say in grade 3, 4, and 5, but still a concept I think that everybody gets at, is can a triangle have an obtuse angle? Can a triangle have an obtuse angle? Well, let's draw an obtuse angle and do that. This was obtuse. So the answer is yes, it can. I think a lot of kids, and I've done this with them because they've asked me or I've questioned them. The immediate knee-jerk answer is that no, a triangle can't have an obtuse angle. But of course it can. All right? So as you get your word problems and different stuff, you have different notions in your head based on what some of these things are or aren't. Okay, so let's try another. If we have two angles next to each other, we have angle A, say here, and B here. These are adjacent. Again, it doesn't matter what we call them. But if the word problem says there's two adjacent angles, you just need to know they're right smash next to each other. Okay, and they create, if you want, a super angle. That's not a formal term, though. Okay, but there's other formal terms for their sum. Okay, for instance, when two angles add up to 90, they call complementary. All right? So, and if they add up to 180, they call supplementary. So luckily, on most of the tests you guys are having, they're not going to force you to know what complementary and supplementary is. If they want the concept there, they'll tell you something like these added up to 90 or something like that. But really, this comes about from the use of a right triangle. If you have a right triangle, then you have angle A and angle B. That has to add up to 90 because the sum of the angles in a triangle adds up to 180. So A and B must be 90 because 90 plus 90 is 180. Okay, on the notion of things like that, a line also has 180 degrees. A triangle has 180. A circle has 360. All right? A quadrilateral also has 360. And you can remember that easy because if it's a square or rectangle, it's 90 times 4. It's 360. Not too often are you going to be asked, at least through grade 9, for the angles of other angles. Sometimes in the integrated algebra class, you're going to be asked for that. In half the cases of that, they're going to give you the formula, which is 360 times n minus 180, or sorry, n minus 2, where n is the number of sides of the figure. So in the case of here, the four-sided thing here, we'd have, sorry, let me rewrite this. It's 180 times n minus 2. So we have 4 minus 2, we get 2, and we get 180 times 2. So if you have a five-sided thing, you get different numbers, okay? So again, we're just trying to process what some of this stuff is about. So let me just put down some notes. So everybody needs to know what parallel lines are. They're two lines that are equally distant from other. They run on forever in both directions. They never meet. And you can remember whether it's parallel and perpendicular often get confused. Parallel, when you write out the word, it has two L's in it. It looks like the two bars being equal. Perpendicular could be done through a T shape or even through an L shape, and that's where you're getting the right angle from. Okay, and we can use some of these to verify it. If there's two 90-degree angles, then the line is 180. So stuff matches up and so on. So I said two supplementary angles that add up to 180. In the case of a line, they're called supplementary. By the way, angles that add up to 360 are called explementary. You're never going to be asked this on a test, so don't worry too much about that. So with all that in mind, let's get into some of the more complicated kind of stuff. So normally when you get these geometry questions, you're going to kind of have three flavors. First of all, there's this kind of scissor thing. And these are both straight lines. So if I have angle 1, 2, 3, and 4, let's say, 1 and 3, I'll call vertical angles. So is 2 and 4. Okay? And in particular, they're equal to each other. So if this and this match, then I'm going to put a double 1 here for this. Okay? And it just means because they're facing each other, right? That's easy to remember. Again, it's called a vertical angle, but we don't really care what it's called. The main thing we want to know is they're the same. So if this is 20, then this is 20. Okay, if this is 80, then that's 80. This can't be 80, but what can it be? Okay, so there's another notion. So if this is 20 and the whole thing is 180, then this must be 160. So this is called the linear pair. Two angles that are formed to create a line. Linear pair. We can also add more. It doesn't need to be constrained to just that. So this is 20, this is 30, that's 50. So that must be 130. So that the whole combo of them all equals 180. So we have two notions here. One is that a line is 180, and the other is that the opposite angles that are opposite to this kind of scissor thing, are equal. Okay, so this is one of the main things. This is the second main thing when we're solving these more involved problems. Okay, the second involves, because it's normally going to have a bunch of shapes. We have two parallel lines. So if A and B, so I can write something like A is parallel to B. I have a line that intersects it called C, and we have a bunch more angles here. So 1, 2, 3, 4, 5, 6, 7, 8 here. So there's a bunch of truisms that are involved in here as well. First of all, if we use the concept that we learned from the vertical angles, we know, for instance, that 1 and 4 are the same angle. So this is where we want to use it in the more involved stuff. Almost all the examples are going to use a triangle and some parallel lines that are traversed in half or something, or the combination of the above, or a circle thrown in. And we can throw a circle in here like this, right? Which means this whole thing is 360. So if I told you this was 100, then that means this is 100. And if the whole thing is 360, we're going to have 360 minus 200. And that's equal to 160. And if this angle 3 and 2 are also vertical angles, which is equal, then we're going to divide this by 2, so this must be 80. And this must be 80. And a weird thing happens if you notice if we go halfway, 100 plus 80 is 180. So we could also calculate it by using that other rule. Right? So some of this is confusing, but if you just go by the linear pair, this here, then it adds up to 180, and that the angles with the vertical ones, the ones just facing each other, opposite each other, are equal. So that's all I did here. And the fact that there's a circle, so that's the third issue, that a circle is 360. All right? And then there's one or two other things that kind of come about from these truisms, just based on kind of these three rules, if you want to work it that way. So if you come back, this is kind of muddled up at this point. So if we have the two parallel lines and the line that cuts through them again, right? So it's still true that A and B are parallel here, and C cuts through. We have something called corresponding angles. This angle and this angle turn out to be equal, because we can see if this is parallel and this cuts through, this is a straight line as well, the angle it's making here has to be equal to the same angle there. This is called the corresponding angle. I like to think of it as a shelf. You're putting the same thing on the shelf at every level. Again, even if there was another parallel line, it's still the same angle there. All right, and there's a couple of ways to kind of prove this again. All right, because if from here to here is 180, and by the way, that means this is also that same angle, and also means this is that same angle. So these four angles are all the same. So let's say again it was 100. So that's 100, and that's 100, and that's 100, just like that. Just like that. And if you notice, we originally started with these two angles, the 100 and 100 here. Look at the one under and the one under also match. Right? So we can add up the line stuff. This is 100, then this is 80. And we can double check it again. 100 plus 80 is 180. 80 plus 100 is 180. 100 plus 80, so this is 80 again. So then this is 80, and that's 80. So we have a whole bunch of lines coming in here. So again, that looks kind of sloppy. But if we kind of get in here, and notice kind of this Z shape here. Okay, I had 80 here. I figured out that was 80. This is also 80. All right? So that's called alternate interior angles. This is considered the interior. This is considered the outside or the exterior. When you have something like this, it's slightly different terminology when you're involving, say, a regular shape or the example I gave before. Anyway, this is alternate because it alternates. Alternate interior angles are equal. Okay? And it means that this here, this one and this one, it's the same thing as the Z shape backwards. So we knew that was 100. So if this is 100, then this is 100. So what we're really doing is dancing around the same issues. And if you notice, there's now something inside of here, this part here, where you have 100 plus 80. So this is 180. So that's another truism. That's always going to be the case. And you can double check it just by using some of these numbers. All right? And that's called consecutive interior angles. But really it doesn't matter. Just remember, if you go through that a line is 180 and the vertical is opposite each other, it's the same angle over here. Okay, and then just go with this kind of shelf thing where this and this are the same, then everything else falls in place. And what you really need to do is practice, because I'm sure if you're following this, you got confused in at least one place, but there are like 5 just simple concepts on how the geometry of the angles all fits together. And it just works out. All right? So that's the main bunch of issues really I wanted to get out to you guys, so that if we try to, you know, and just to kind of double prove it, if you had 2 parallel lines and you run a perpendicular line down it, that means this is 90. It means it's 90 there too. But if that's 90 and this is a line, then this is 90. And that means this is 90. But then these over here also have to be 90 as well. All right? So look what we have, a way to memorize it. So if we had 2 parallel lines and we just draw a perpendicular line through it, okay? Give me 1 second. I'm getting an urgent text. Okay, so this is kind of a way to memorize it all. That we have this infrastructure built out that if this is 90, then that's 90. And everything else kind of comes about it based on that. So there's other ways to do it, so that if we kind of are using some of what we just did again, there's actually some other terminology based on some of these lines. So, for instance, I covered the one where those are equal. There's another where this and this are equal. And we can run through that to prove it's the case. If this is there, then this is the same as that. And now these vertical angle match that, and now the corresponding angle is the same. So we could get something like here and here being equal. We don't have to memorize it. We can just run through it. Okay, and that's called alternate exterior angles. But again, who cares what it's called? And if you only memorize the 3 or 4 basics, you can always recompute this every time. Because really what matters in a lot of these examples, they're going to have something like 50 here. And they're going to ask you what x is over here. So if you just keep reapplying these rules and traversing through, you'll get there. Let me see, is there another one I left out? No, I think that covers the main ones. So if you end up having something like this, and they tell you that this is 20, right? And they want to know what x is here, that should be easy peasy for you. And you can do it multiple ways. You can memorize all the different rules, or you can just compute it. This is 20, right? So then that's 20, and that's it. You solved it. Okay, and there could be other shapes drawn through this. Whereas if there was a line here, like this, they might give you some other information. Like this is 90 degrees. And then they may ask you what this angle here is, y. Well, the original thing they gave you here was that this was 20, then you make that 20, and you have 90 plus 20 is 110, so this would be 70. All right? And there's other thoughts here too, because if you're getting this here, right, it also means you're talking about this line. So they may have not asked you for this angle, they may have asked you for this Z over here. And if you just keep reapplying these rules carefully, because what happens first of all is you have to go through the gymnastics of trying to figure out what these three rules are and applying them consistently. But often you're subtracting from 180, from 90, or 360. In a few cases, 270, just because you can go 3/4 of the way around a circle or something like that. So normally you're subtracting from those kind of three things, and you often make an off by, not an off by 1 error, but an off by 10 error. You either add 10 too much or you subtract 10 too much. So instead of this being 70, you might say it's 80 or 60, okay? And then it gets uglier when for instance, this may have been 25 or 75. Then you're going to be off by 5 often. So what you want to do is, once you figure some of this out, maybe do another clean version of it once you did all the calculations, and just make sure things add up to 180 or things add up to 360 or whatever the case may be. And again, you remember you're in a lot of these standardized tests, you're playing against the clock, so you have about 1.5 minutes to solve the problem. And so far I'm really talking about doing this as a grid-in problem. So hopefully these are grid-ins. But often if they give you the A, B, C, D, they're going to have the off by 5 and the off by 10 answers as one of the choices. They're going to, because especially if you have to do a double thing where you have to subtract from 180 and also consider 360 and also consider a 90-degree angle depending on how they set all this up. But sometimes these can be complicated. All right? So I think we bit off a lot today. And please, again, like this video. Please subscribe to my channel. And we'll just keep chugging along. Yes, there's a weird circle for you guys. All right, everybody, have a good day.